questions were, find the value of x that makes the lines parallel. And all that means is that you're working backwards. You're identifying what angle pair they have to be, and then are they going to be equal to each other, or are they going to be supplementary? For example, in this case here, these two guys are in the same position on the same side, which makes them what angle pair? Corresponding, which means they have to be equal. So you say corresponding angles are congruent, so you would just say x plus 1 is 110, x is 109. And that's how you would do those. All right, so I know that on the calendar I had posted the
Did you make any funny jokes during the video that we couldn't hear?
No, I think it was pretty boring. On the calendar, there was that 3-3 worksheet done. You guys can give that to me on Monday if you didn't understand what was going on. It was just working backwards, all right? So if you figured it out, great. You don't have to worry about it over the weekend, but if you didn't, you're just working backwards. That's what it was. Cool, then you don't have to worry about it obviously until Monday. Joe,
Yeah, we had to.
the other. Hey! Yes. Going back to seems like a week ago, you guys had this sheet. We did a little bit of this after we started talking about constructions. I will take that one now, please. That's what that looks like. First page looked like that. Told you not to do those first four. There's a whole bunch of angle pair stuff. Yes, ma'am, that's correct. The bottom page number, it says 3.2 practice speed. The bottom page number says 21. I'll take that one now because I will take the other one on Monday in case you didn't know how to do it. Because now you know it's just work backwards. I can't hear you. Everyone's talking.
Now you want that.
Yes. It's on the calendar. Obviously, we are on our second Friday of the week today. It's also kind of like our second Monday of the week, if you really think about it.
You know what? Don't bring up Monday.
All right, anyway, so today we're going to start out with the 3.5. Don't come here tomorrow. We're going to finish 3.5 on Monday. Do a little bit of review jump that I have for you, which will tie back into that 3.3 that we've seen. Yes, I have skipped section 3.4 for right now. Section 3.4 happens to have just two measly theorems in it that really don't have any algebra problems to them. So I'm just going to talk about those when we do some review stuff, which gets me to Tuesday. It's all review stuff. And on Wednesday, it's going to be our quiz. I will forewarn you. No, not yet. That will be probably the following Friday is my best guess. I will forewarn you on this though, guys. After we get through this first chunk of 135, it makes a really hard right turn back to Algebra 1. It goes back to writing equations of lines. Writing equations of lines that are parallel, writing equations of lines that are perpendicular, slopes, point slope, slope-intercept form, all that fun stuff. But we do it in terms of geometry and coordinate plane a lot more. So all that stuff that you spent a good solid month on in Algebra 1, we kind of bum rushed through in about 3 to 4 days. It is a ton of review of it, but it's one of those context things that comes back throughout every single math class. There's always going to be rise and run, there's always going to be slopes, slope-intercept form, visual representations. As you get into Algebra 2, or actually even in geometry later on, we're going to talk about the equations of lines that are tangent to circles. We still have to go through the same process of how these things work. Okay? We have a lot of equation writing to get through. In Algebra 2 next year, you're going to write equations of lines, quadratics, nth degree polynomials, logarithms, exponential functions, sinusoidal, which means sines and cosines, things like that. There are so many different things we do in terms of graphs and equations, and it's just one of those things that just gets rewritten over and over and over again. Okay, so in geometry, just so you know, we kind of do the same thing as you did in algebra. But with today, then, what I want to do is spend time on talking about 3.5, and it talks about the triangle sums. And exterior angles. Okay, so let's get through this stuff. We haven't had too much of a hassle running through those things at all today. Make sure you go through all the files and pass them backwards. Thank you. And turn off the phone, please. Thanks. All right, guys. So what we're looking at here is what we call triangle sums and exterior angles. So really easy. How many degrees are inside of a triangle? 180. You guys all knew that. There wasn't anything new. You've learned that a long, long, long time ago. So what we say is the sum of the interior angles in a triangle always equals 180 degrees. Always. Or does it always? This is not a ball, it's a sphere. Okay. It's a sphere. A sphere is basically it's a three-dimensional circle. Okay. Now, if you think about it in terms of a globe, the line around the middle is what we would call the equator, right? Okay. The lines coming down the side of the globe are the longitudes, I believe. And longitudes are always perpendicular to the equator. So I could have two longitudes perpendicular, and those two longitudes could meet up at the north or south pole and also be perpendicular to one another, which therefore creates a triangle with how many right angles? 3 of them. And last time I checked, 3 right angles adds up to how much? Not 180. You're right. Well, what's 3 times 9? So add a 0, you get? So there you go. Is it possible to create a triangle with more than 180 degrees? Yeah. But do we deal with it in terms of high school geometry? No. It's just something kind of cool to show you. So you can see it. Because you can see it then as, because what happens is with the curvature, it allows for that to work.
Oh my God, this is good?
Yeah.
I was kidding.
Oh. That's not good. So the sum of the interior is always be 180. Now that means you have interior angles. Everybody all right with that? Now with each interior angle, there will also exist an exterior angle. Each interior angle has its own corresponding exterior angle. Now, you might notice rather quickly that there's going to be some relationship between interior and exterior angles. What's that? There's some metric. Very good. Very good. Notice each interior and exterior angle create their own line, don't they? So exterior angles, we define it real quick. An exterior angle, it's real tough, isn't it?
So hard.
Is an angle on the outside of a polygon. What's that? Now, the reason why I'm saying polygon and not just triangle is because all of our polygons have interior and exterior angles as well, and I'll show you what goes on with those here in a second. Now, just like John just said, that interior and exterior angles are always going to be supplementary because, as you see, they always create lines.
What's a polygon?
Many-sided figure. Polygons are you have concave or convex polygons. Normally we talk about what are called convex polygons, rectangles, triangles, hexagons, pentagons, things like that. Okay. Polygons just stands for many sides. Sign. Yes?
John wants to know if a circle is a polygon.
It is not. A circle is not a polygon. A circle is not a polygon because a circle is defined as a set of points equidistant from a center point. Whereas you get to a polygon, polygons, no matter what, there's going to be a center value. The distance to a vertex is always going to be longer than a distance to a side. No matter how many things there are, but eventually you will, but you can inscribe a polygon within a circle. Because what happens then to the center to the vertex is called a radius. You're about 7 chapters ahead of me right now. So go home for about 3 months and we'll talk then. Okay?
I will definitely go home.
Now let's think about again that interior exterior angle thing. Guys, don't have that much to go through, but I want to get it all done here today. So let's say you've got an interior angle of 52 degrees and you've got another angle here of 61. Do I have enough information to figure out what that exterior angle is and what that other inside one is?
Yeah.
Okay. To get the exterior angle, what do I do?
You would just subtract.
Yeah, you just subtract out from 180, right? Okay, so what's 180 subtract 52? You're 128, okay? So my exterior angle, how do I figure out what that is?
Well, one should be the same.
If I have to do what? How many degrees are in a triangle? Okay.
Yeah.
Subtract the 61, subtract the 52. Okay, so you're going to subtract 103. What do you get? How much? 67, okay. I don't care if either of you are bald and or ugly, I would like you both to be quiet. So, what's 61 and 67?
That is.
Huh?
Wow.
Sneaky.
That was lucky.
Back on the scale. What's left over for the what's left over for that one interior angle?
That's not.
I put a right angle box there. It's not drawn to scale.
I can.
This has to be What does that have to be? 35, okay. What's 55 and 90? Okay. Let me redraw this one. No, I'll just do another one. Do those two have to be the same? No. They just have to have to 100. They don't have to be the same. If they were the same, you would have this. Then they would both be how much? It'll be 50. But I can't, oops. I can't assume that because it doesn't say that. You're going to say something.
Yeah, I was just about to say something.
Oh, great minds think alike. As air quote great. So that means what's the other one have to be? Has to be 60. Okay. What's that exterior angle have to be? How much? 120. What's that exterior angle have to be?
Yeah.
So, I don't know if you quite recognize this yet. 140, well, doesn't that equal 80 plus 60?
What are you doing?
Wizardry.
It's like the exterior angle is the opposite interior angle is equal.
Whoa.
And then, what about that last one? It's gonna be the other side, isn't it? And you did some really good coloring.
Sorcery.
Scientific notation.
Yeah, it's so close to that. The exterior angle always equals. You can say the opposite to
Why did you
interior.
wait so long to tell us this?
Because you know what you did? You just figured it out. I didn't have to tell you. You know why? Now you'll remember it more.
Maybe. I forget a lot.
The exterior angle is always equal to the sum of the two angles. It does not touch. And that is a lot less wordy than what you were saying. You're right. It's the equal to the sum of the two opposite interior angles. Okay? That's perfectly correct. When you describe it is the exact definition. But I don't like a lot of exact definitions. I think it's a lot easier. Yeah. I've been going for a while. You need to write stuff down. Otherwise, we can rewrite stuff and make it easier for our brains to think about. That's what I do. Yes, ma'am. Yes, ma'am. So the exterior angle will always equal the sum of the two that it does not touch. Okay? The exterior angle will always equal the sum of the two it doesn't touch. Now, that only works in triangles, though. Okay? It only works inside of a triangle. Because we talk about, and I had mentioned this earlier, guys, please, it's getting old real fast. I haven't had to make the full seating chart, but trust me, it is not that far off. But the chit chat back and forth is getting really, really on my nerves. I know it's like another weird day again, but come on, bear with me. We have a bunch to finish out here. One of the things I was going to show you guys is that as you start going through your shapes, and we do spend a ton of time on this later on in the semester, as you start to go through this, a four-sided figure allows you to draw two non-overlapping triangles, which means each of these triangles has 180 degrees in them, which means a four-sided figure has how many degrees? 360. Each four-sided figure has 4 exterior angles. 5-sided figure, you can draw 3 of them, which gives you interior of 3 sets of 180. 540. It's irrelevant for right now. But again, you're able to get yourself how many outside angles? Then you get 5 of them. Same thing happens when you have 6. You can draw 3 of them. You guys don't have to draw all this out right now. I'm just trying to show you a little trick that's happening. Why this happens. You get 6 outside angles. Now, if you're outside of something, you have to figure out how many degrees it takes you to get around something. If these are squares, you get pound them. Now, how many degrees does it take? How many degrees are on the outside that are on the outside that at the inside all have 90 degrees? What's the exterior angle of 90? 90. So 90, 90, 90, 90 gives you how much? It would be how many degrees to get around it? How many degrees do you think it takes you to get around this? And then how many degrees to get around here? As we go further along, when we get to the... Sorry, this one. And as we get further along, one of the things you guys will notice is that we spend a lot of time talking about regular polygons. And polygons have a lot of properties to them, but it all comes back to this idea that inside angles of a triangle always add to 180. Outside angles of a figure always add to 360, no matter what. Okay? So this is why we teach this now, because we're going to use this a lot throughout the course of the semester. And as well, like John was saying, when you're asking a question about the circle being a polygon, when we get to areas and stuff, we have to redo all that again. So.
Yeah.
Let's do some problems. Yep. So what we're going to be looking at then is there going to be enough information to help us figure out missing angle degrees?
Indeed.
Okay. So when you have a problem like this, and we're going to have this is the examples I'm going to start showing you now are going to be very similar as to what you're going to look at for homework. So it would be recommended to actually, draw pictures and diagrams and things that help you recognize what to do. Now, as you go through these things, are there any exterior angles that it's asking you to solve for? Nope. These are all interior, which means you have to deal with the sum of the interior of a triangle, which means each triangle has to add up to equal how much? 180. Good. What does that little box mean in the corner?
90.
What's left there for angle 1?
90.
60. So right here it has to be 60. You okay with that?
Yeah.
What does angle 2 have to be?
30.
Why? What are those called?
Vertical.
Very good. They're vertical angles. Remember the whole thing when we talk about vertical angles occur when you have 2 lines that intersect? When that happens, when they're opposite one another like that, they're always going to be equal to each other. So that's got to be a 30. As we think about it, this would have to be 150, which makes that 150, which makes this 130. 30 and 70 is how much? What's left over then for angle 3?
80.
Pretty easy, isn't it? Okay. That's what we're looking at being able to do today, guys. Solve missing angles and work our way through a problem. The tricky part really does become where do you start? A lot of students have just a heck of a time trying to figure out exactly where to start a problem. I'll show you one more of these. Does anything change when you have an ugly diagram?
Yeah.
And quite honestly, the most difficult thing about this problem is to draw it. So here's how I would draw it. Just go down, up, down, up, down. Close enough, right?
That's all right.
when you draw that out, what is it forcing you to solve for first? Which one? One, yeah. It's forcing you to solve for angle 1 first, because that's the only one you can solve for. So how many degrees are in that triangle? 45, 65, and 1. Well, it should be 180 degrees total, right? So what are you left with then for angle 1? 70. Are you okay with that? So angle 1 gives you 70. So if I have 70 degrees here, now take a look. 70, 45, and what create a line? 180. So what does angle 2 have to be? It's got to be 65, doesn't it? 70, 45, 65 gives you 180. The reason why I can say it's 65 quickly is because notice you just had a triangle with a 65, 45, and a 70. In this case, yeah, we can do that, but you'd have to say that that one's parallel to go through, and then you'd have the 65. Yeah, that would be okay. Because that's another way of proving that just those two sidelines are parallel. Doesn't say anything about the other one. Yeah, yes, sir. Help yourself, man. Passing through the back. Now you have another triangle, aren't you? 65 and 20 is how much?
85.
Subtract it from 180, what are you left with?
95.
There you are. See how fast that can be? It's just a matter of looking at the diagram of what information you have and what information you can jump for right away. It works out rather quickly. There's not a lot of math here. Does any of this change if I throw algebra in it? Nope. None of that changes at all. For example, if I want to figure out what, excuse me, if I want to figure out what angle, or not angle, excuse me, what x is equal, I want to figure out what x is equal to, what do? Perfect. You add them all together, set it equal to 180, because aren't those all interior angles of a triangle? Ding, 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 ding. So all you have to do then is 2x, 3x, 55. It's super fast. The math doesn't change. It's the idea of, well, are you working with all your interior angles, or are you working with your exterior angles and going from there? It's super quick. Not terrible, right? Cool. Two-step equation, man. Two-step equations. Oh, I gotcha. Gotcha. Oh, I'm sorry.
You heard me?
There's that. Okay. Yeah, you're working with an exterior angle. 4x and 8 is 2x, 3, and 51. Combine it out, we get 4x plus 8. Okay. Variables on both sides of the equation, who are you going to pick on? Little guy. Is it okay that I subtract 2x here and subtract 8 at the same time? We get 2x is, was that 46? X is?
23.
Remember, guys, the algebra math that we do really isn't any more complex for right now. 1 and 2 step equations, maybe 3 here or there. Okay? It's the idea of, can you take the geometric terms, flip the switch over to the algebra, all right? Homework-wise, though, I've got problems for you, and I'll put them up on the board here like this. And I want to walk you through how you set up one of them, because I found it can be a little bit tricky if we're not careful.
Is that out?
Yes, sir.
Hey Murphy,
Yes, ma'am.
so could you do like 4x plus 180?
4x.
Like right here?
We
Did that
don't,
equal 180 with having a
no,
smaller-
we don't know, because we don't know what that inside angle is. This angle, let me see if that's what this angle is for here. And this one is equal.
No.
All right. The problems, these are all in the regular old boring textbook. The link, you'll have to follow the whole links. The 15 clicks to open it up. It's awesome, and then you're ready to find the textbook. What I want to do here after you write that out is I want to show you guys one of the more, I wouldn't say it's complicated, but it's one of the problems that looks kind of weird if you're not careful about where to start. Okay? Can I pull it up real quick? This is number 31 out of those problems. Okay. Number 31 is asking you to find, I think, 5 different angles, A, B, C, D, and E. So I would, take a second, draw that real quick. You might as well do this as your first problem. And I'm going to show you guys what I would do when I see an ugly problem. Yes, ma'am. This is 31. Let's try that. There. Now we know. Now, when I'm dealing with these, types of problems, guys, there's always one spot that's easier to start than others. It's a matter of, can you recognize where that is? What's that? You start at B. Perfect. Absolutely perfect. The reason why I would start at B is because you've got this right angle here, which means these two angles have to equal how much? 90. It's got to be 90 because it's the right angle. So if I do the 90, subtract the 32, you get how much? I'll math it. 58. Now, by doing that one there, that 58 degrees, that opens up angle A, doesn't it? Which then opens you to get the supplement for angle C, which then opens up for the next triangle here to get to angle D, and so on. So it's the idea of where you don't always start at A or B or C. It's which one has the right amount of information for you. You can kind of unlock the rest of the problem. And as we get going further into in geometry, we'll see big picture problems that have 10 different questions built into it. And it's a matter of where is the best place to start. And I had a student last hour said, hey, I'm going to get angle C first. And that's fine, because you get angle C, then you can you get that one, then you can figure out what angle D is because you've got that triangle. And then you'll have angle D, the right angle gets you angle A. There's a couple of different ways of going about it. I just always thought that angle B was the easiest one to do because I can start with small stuff and work my way out. We okay with that? See, I see what you did there. Which one? Okay. We'll get started, we'll go through this stuff. So remember, on Monday, you have 2 things. You have that 3.3 stuff from Tuesday. And then we have this 3.5 stuff. Alrighty.